Hi, good day everyone. Today we're going to learn on Chapter 1, Form 5 Chemistry. The topic we're going to do a quick revision today is on redox equilibrium. Okay, before we start on redox, let's check what we have to be focused in this topic here. Okay, now other than that, you learn separately on electrolytic cell and chemical cell, which are vortex cell. Okay, you should be able to compare and contrast between these two cells. In terms of the type of cell, you must be able to recognize the cell, whether they are electrolytic cell or chemical cell, and you should be able to write the half equations for anode and cathode of the respective cell, and based on the reaction that occurs at the anode and cathode, able to define whether it's oxidation or reduction. And as usual, just now I told you, the observation is very important. You're only able to deduce the correct observation by knowing the product formed. So for you to determine the product formed, you should be able to determine the discharge of the ions based on the correct factor. Okay, beside electrolytic cell and vortex cell, which you'll be learning in this topic, there's another part you have to focus to on the conversion of iron 2 to iron 3 and vice versa, and also the process of rusting. Okay, when we are talking about iron 2 to 3 and vice versa and rusting, what's the very important thing you have to focus to on the process that involves, especially on the transfer of electrons at distance for the conversions. And then you should be able to write the half equations, and based on the reaction you must be able to classify whether the reaction is oxidation or reduction. Upon assigning whether they are oxidation or reduction, you also must be able to define whether they are oxidizing agent or reducing agent. Okay, so observation, name of product, and the confirmatory tests for the product formed are very important for you to focus to, and you should be able to describe correctly the experiment involved on rusting. Okay, so generally when you look at this topic, the very important skills the students have to enhance is on writing equations. Okay, you must be able to write the correct half equations, ionic equations, and how the conversion that's occur from atom to ion or molecule to ion. This is very important because this is the common errors of the students. Okay, now let's look at this question. State all the ions present in molten lead to bromide. Okay, students, I want you to focus to the word molten. Okay, whenever you hear the word molten, the first thing must come to your mind is there's no water. So you only will get the ions of the respective substance. So right now we are using lead to bromide. So you only have one positive ion and the negative ion which comes from the substance, which is lead 2 ion and bromide ions. And the question asks you to state, so you can use a formula, no problem. If you don't want to use a formula, then you want to spell out also can, but make sure when you write your lead 2 ion, you put the Roman 2. If you write lead ion, it's wrong already. Okay, so when you want to spell out, you have to be careful. Next is sodium sulfate solution. Okay, can you see the word solution? Whenever you hear the word solution, you must know there is a presence of water. When there is a presence of water, additional to the positive and the negative ion of the substance, you also have the ions come from the water, which is hydrogen ion and hydroxide ions. So for solution or aqueous, whenever you hear this type of words, you should know there's a presence of water. Whenever there's a presence of water, you'll have 2 cations and 2 anions. So right now I'm using sodium sulfate solution. Thus I'm having sodium ion, sulfate ion, and I told you, right, solution must have water, so there are also additional hydrogen ion and hydroxide ions. Now let's look at this question. They said based on experiment 1. If you look at just now, I have shown you two setups. So when you read your questions, please be careful. Which setup are they talking about? So over here, they already clearly mentioned it's about experiment 1. So you just focus to the setup 1. Okay. So now let's look at the question. What the requirement of the question? They ask you to name. Okay. The keyword here is name. When the keyword is name, then your answer must be spelled out. So name the gray solid produced. Okay, so now before you name the product, you have to do a little bit of analysis to the questions. So now as you can see here, you must be able to identify the terminals correctly. The long leg will be the positive terminal, the short leg will be the negative terminal. And remember, I told you just now, molten don't have water, they only have the respective ions. So right now, I'm using lead-2 ions and bromide ions. So there's only these two ions are available in this setup. So based on your chemistry knowledge, you should know that the positive electron will attract the negative ions towards it. Okay, so bromide will move to the anode, and in return, the negative electron, which is the cathode, will attract the lead-2 ions. So here they say that gray solid produced. So students, you have to be very clear about the product formed based on the ion discharge. So right now, if you look at anode, the bromide ions attract to the anode. When bromide ions discharge, it will form bromine gas. Bromine gas will be brown gas. Observation will be brown gas. The name of the product will be bromine gas. Okay, but look at cathode now. When lead-2 ion discharge, it will form lead metal or lead atom. So the lead atom is the gray solid. So here they want you to name the gray solid produced. So the product they are mentioning here is about lead. So you can write lead metal, or you can say just lead. You will be able to get the marks, full marks. Okay. So now the second part you have to be mastery is about writing the half equation for the formation of gray solid. Okay, now let's look at this part. At cathode, the lead-2 ions will be discharged. Now how the lead-2 ion going to be discharged? It need to receive 2 electrons. Hence your half equation going to be Pb2 plus going to receive 2 electrons, hence it forms Pb. If you look, everything is balanced up already. So 2 plus, that means lack of 2 electrons, you receive the 2 electrons, it becomes neutral atoms. So this will be the half equation for the gray solid formed. Now state the observation at anode. So now go back to the anode. As I told you just now, you already do the analytical analysis already, which is bromide ions attracted to the anode. So when bromide ions attracted to the anode, what happens? The bromine gas is produced, which are brown gas. So here the question 1, observation. So observation, we talk about color, don't ever mention about the name. So the observation will be brown gas released. Okay, now let's look at this question now. Based on experiment 2, so we just forgot to setup 2. Name the ion discharge at the anode. So before you identify the ion discharge at the anode, the question asks you to name, so you have to spell out. Now, what are the steps you have to follow is, as usual, you have to go and identify the positive and the negative ions in the setup. Remember, the long leg is positive, short leg is negative. and upon that go and look at your solution. Can you see the word solution? That means remember they must have 4 ions, 2 positive ions and 2 negative ions. So sodium ion, sulfate ions, hydrogen ions and hydroxide ions. And then based on the terminals, go and put up the ions which are attracted. So positive ion will attract the negative ions, negative electron will attract the positive ions. So now they are talking about anode. What's the meaning of anode? Anode is a positive terminal. So look at the positive terminal. Which ions are attracted? Sulfate ions and hydroxide ions. So when we are talking about sulfate ion and hydroxide ions at the anode, we have to look for the when we are talking about at anode, the negative ions to be discharged. So you have to determine which factor is it going to affect the ion discharge. So as you have already learned, you look at the concentration. When the concentration is not mentioned, that means it's dilute. Okay, and the type of electrode used here, both are carbons. So in that sense, the type of ions to be discharged is determined by the E0 value, the standard electrode potential value. So you have to rely on the E0 value. You can refer to the table will be provided during your exam. So when we are talking about anode, we go for more negative value, E0. So if you compare sulfate ion to the hydroxide ions E0 value, the hydroxide E0 value, E0 means standard potential value, is more negative. When it's more negative, we choose hydroxide to be discharged. So in this case, the ions to be discharged will be hydroxide ions. Make sure you write the word ion at the back. If you didn't write the word ion, you just write hydroxide, is wrong. And next, state the product of electrolysis at anode. So students, you must know this is quite very famous half equation to be questioned for hydroxide. Most of the solutions, the anode, if you are based on standard potential value, the hydroxide ions will be discharged. So the half equation will be 4OH negative, arrow out, O2 plus 2H2O plus 4E. So here the product formed will be oxygen and water. So they said state, so you just write oxygen and water. If not, you can also write like this, O2 and H2O, correct, because question asks you to state. Now how about cathode? When it comes to cathode, again we have 2 sodium and hydrogen who will be discharged. Hydrogen ion is discharged again based on E0 value. Okay, because of E0 value, this is more electropositive. So hence the hydrogen ions will be discharged. When hydrogen is discharged, the half equation will be it has to donate. So when it has to donate, your half equation be done. Okay, your half equation here, originally it was hydrogen ions, so it's coming to hydrogen molecules. How it forms by donating is electrons. So you balance out. This is a half equation for hydrogen. So the product formed will be hydrogen gas. So name another solution that gives the same product. When they request you to state another solution, the simple one what I will suggest you is you just change the anions. Now they use sodium sulfate, right? You just change the anions and make sure the salt are soluble. So we know that based on your salt knowledge, all nitrate salt are soluble. So the easiest one, you can substitute the sulfate to nitrate. So sodium nitrate solution, or you just take out the sodium, substitute the sodium with potassium. Isn't it all the potassium salt are soluble? So just change the name. Either you change the positive ion or the negative ion. No need to think so hard about it. Okay, it's actually easy only. Okay, let's look at this question now. They have make sure, okay, one more thing I want to tell your students, make sure you read the head of the questions. Don't just jump to the conclusion by looking at the setup. Okay, try to understand the question. What is this setup is about? This is to study the electrolysis of 1 molar copper 2 sulfate solution. That's okay. So in set 1 they use carbon electrodes, set 2 they have used copper electrodes. So by reading this, you already have the clear picture, or even you observe also you can see it. Set 1 they use carbon electrode, set 2 they use copper electrodes. So when the electrode changes for solutions, then the factor we use for ions to be selectively discharged will be differ as well. How? Okay, so now let's look at this type of questions. So what I will recommend you all to do is, please do an analysis to the diagram first. Make sure you understand the diagram. So you can construct a table like this. Okay, this is what I always propose to my students to do, so that you will get a clear picture about what really happens to the setup. So first thing, students, what you have to do is, when you get this type of setup, go and identify the terminals, positive and the negative terminals. And then the second one, based on the solution, identify the ions. So you can see copper 2 sulfate solution. So copper 2 ions presence will be copper 2 ions, sulfate ions which comes from the solution. And can you see the word solution here? So that means there is a water, so you must have hydrogen ion and hydroxide ions. Okay, now upon you identify the ions present in the solution, what I want you to do is go and determine which ions among this four, which one going to go to the anode, which one going to go to the cathode. Okay, so can you see this is a positive terminal, so it attracts the negative ions towards it. So the negative ions here will be sulfate ions and hydroxide ions, whereas the negative terminal, which is the cathode, will attract the cations towards it, which are the positive ions, Cu2 plus and H plus. Okay, so now let's go and write down first. At anode there are 2 ions will go there. What are the 2 anions go to the anode? Sulfate and hydroxide. Whereas for the cathode will be copper 2 ion and hydrogen ions. Now there are 2 ions at the anode, there are 2 ions at the cathode. So we have to do a selection here, which ions to be selectively discharged. So when we are talking about selective discharge, students, I want you to look back to the factors to determine the selective discharge of the ions. So right now you look at the anode. They have used 1 molar. 1 molar means it's concentrated already the solution, and the carbon electrons. So because the solution is concentrated, so we use concentration factor. But remember, for the anode, okay, here is a very important remark here. Make sure you remember this. Even the solution is concentrated. 1 molar above is considered concentrated already. When the solution is concentrated, if you want to apply the ions to be discharged based on concentration, it's only applicable for halide ions. Okay, what's the meaning of halide ions? If it consists of chloride, bromide, iodide, then we choose the ions based on the concentration from the solutions. Other than halide ions, if none of this present in the solution, then we have to select the ions based on their standard potential value. Okay, what type of standard potential value we have to consider for selection of the ions to be discharged? That should be more negative value or less positive value. Okay, this is the fact that we have to follow when you want to choose the ions to be selectively discharged for the anode if the solution is concentrated. Again, I would like to emphasize here, concentration is only applicable for the anode with condition the solution consists of chloride, bromide or iodine. If none of these ions present, then we go as usual. We select it based on standard potential value, where which one consists of E0 value, whether which one is more negative or either to be less positive value. Okay, so when you check it out, you will see that hydroxide ion has more negative value, hence we choose here based on E0 value. Okay, so ions discharge is going to be hydroxide. The reason is because of E0 value, more negative. Okay, next, when come to cathode, we go back to the basic factor which based on concentration. So when you look at concentration, copper 2 ions come from the solution, hydrogen ion is from the water. So whatever ions in the solution should be higher. So in that sense, copper 2 ions concentration is higher, hydrogen ion concentration is lower. So we will choose copper 2 ion. The reason is concentration of copper 2 ion is high in the electrolyte. Okay, so now after you decide or determine on the selection of the ions to be discharged, now we're going to write the half equation. So at anode, because hydroxide is discharged, so as I told you, remember this is quite famous half equation. If you can't understand, you're unable to write the balance half equation, you better memorize because this is very famous. 4OH negative will form O2 plus 2H2O plus 4E. Whereas for copper 2 ions, when it's discharged, it will receive 2 electrons and form copper metals. So this is the half equations. Next, we're going to determine on the observation. When we are talking about observation, students, please look at the product formed. Don't ever mention the name of the product when come to observation. You have to think about the color. So oxygen and water, so oxygen, we mostly focus to oxygen. So we will write colorless gas. You can say gas bubbles or you just say colorless gas released. Okay, usually you see the bubbles lah. So you can write colorless gas bubbles released. And for cathode, remember this is carbon electrons. The color of carbon electron is gray. And what's the color of copper? Copper metal, it will be brown. So will you be able to see anything depositing on the gray surface or not? The brown solid on the gray surface easily can be seen. So you can write your observation here for copper brown solid deposited. Okay, so now we are talking about confirmatory tests. Usually confirmatory tests we talk about gas or the ions present. So over here, because the gas is oxygen, so students, make sure you write correctly. First of all, you have to say what we're going to use to test the oxygen gas. Are we going to use glowing wooden splinter or lighter wooden splinter? That's the first thing you have to ask yourself. So because oxygen, we will use glowing wooden splinter, it will rekindles. If it's hydrogen only, we will use lighter wooden splinter. It will extinguish with a pop sound. And one more thing is the position of the splinter. Where are you going to put it? If it's oxygen, you have to place it into. So you have to say, place a glowing wooden splinter into the test tube containing the gas. Okay, this is very important. Just don't stop at into the test tube. What type of test tube? It must consist of the gas, then only you can confirm it. So containing the gas. So what you say? The result will be relights. So the glowing wooden splinter will relights. Okay, that's how we write the confirmatory test. For copper metal, there's no confirmatory test involved. So remember, confirmatory test is only particularly for gases or the cations or anions to be tested. Okay, so now let's look at this setup now. In setup 2, again students, please construct this table to analyze the diagram. So first step, as I told you, what you're going to do is identify the terminals. This is a positive terminal, this is a negative terminal, and then go to the solutions. Look at the title, the name of the solution used, copper to sulfate solutions. So the ions present is going to be copper to ion. Sulfate ions come from the substance, and because got solution have water, so they will have additional hydrogen ion and hydroxide ions. So now we're going to analyze. Among these four, which ion will go to the anode? Which ion will go to the cathode? So remember, anode is positive, so negative ion will go there. The negative ion from here is sulfate ions and hydroxide ions. Whereas for cathode, the cations should go. The cations will be attracted here, will be copper 2 ions and hydrogen ions. So now we have 2 ions at each terminal, so we have to do a selective discharge of the ions. So now please go and consider about the factors to be applied here for selective of the ions to be discharged. So please look at the electrode used. The electrode used is copper electrode. Copper electrode is called as active electrode. So remember, copper or silver, this is considered active electrodes. When we use active electrodes, so the factors we have to use is type of electrode. Okay, and one more thing I want to remind you here. Type of electrode is only applicable for anode. When you want to choose your selective discharge of the ions, you only have to consider on this factor for the anode. Cathode, we go back to anode. We choose based on anode values. Okay, so now as you can see here, at anode there are 2 ions are attracted, sulfate and hydroxide. So because we use active electrodes which are copper, so hence the anions won't be discharged. In return, okay, there's no ions discharge. In return, the active electrode, which is the copper electrode, will be discharged by donating its electrons and forming the respective ions. Okay, when it comes to cathode, as I told you just now, you have to go and choose based on the anode values. So please go and choose the more positive value of the anode. So if you compare copper 2 and hydrogen ions anode values, so copper 2 ions anode value is higher, so that we choose copper 2 ions to be selective discharge. So the reason here, active electrode, so we use type of electrode. Okay, for here, copper 2 ions anode value is more positive than anode value of hydrogen ions. Okay, now we're going to write the respective half equation. We already identified for anode the copper electron going to discharge. So as I told you, copper, because it's active, it will form the respective ions by donating its electrons. In return, at cathode, the copper 2 ions will be discharged by receiving the electrons and form the copper atom. So now we're going to write the observation. Look at the product formed. when you want to talk about observation, as I told you just now, you have to mention on the color. Okay, so remember, here we are using copper 2 sulfate solution. Copper 2 sulfate is already blue. So do you think you will see any differences in the product formed? Because it also copper 2. So the blue and is also forming blue. So you won't see any changes at the anode. Hardly you can observe it. Okay. But when come to cathode, this copper is a copper atom, copper metal. Okay. Copper metal should be brown color, isn't it? But look here, we are using copper electrodes. When the copper electrode is used, it's already brown there. So will you able to see the new deposition of the brown solid onto it? Unless you have a very bionic eyes, you're able to visible to see it. So don't ever mention, when we are using copper electrode, when there's a copper is formed, then please don't talk about the colors. We talk about the size. So because hardly we can observe on the color, it's already brown and brown is depositing on it. Okay, it's quite difficult to mention on the colors. So in these circumstances, what you have to do is you have to talk about a mass or size. So what do you think will happen to the mass or the size of the electron? Increases, because there's a new deposition of the copper to it. So the size or the mass will increase. So now the name of the product for anode will be copper 2 ion. Okay, but the name of the product form for the cathode will be copper metal, or you can write copper atom. So the word ion and metal, it makes a lot of difference here, so please be careful. So we have analyzed both the diagrams given in the questions. So now we're going to answer the questions. Trust me, it's really worthwhile for you to do the analysis as how I taught you just now. So once you have done your analysis completely, then it will be much easier for you to answer the questions. So now let's look at the first question. What is the meaning of anions? So remember, anions are positive terminal. I told you already, it must attract the opposite one. So when it's a anion will go to anode. Okay, sorry. Anion will go to anode. So anode is positive, right? So when anode positive, the anion must be negative. So negatively charged ions. And see, all the ions, anions and the cations. So they are asking for both. So go and write the respective one. Just now we already classified, right? You just take your answer from the table you have analyzed, you put in. Question asks you to state, so not necessary to spell out. You can use a formula. Now, they said that based on set 1, write the formula of the ions which is selectively discharged at the anode. So just now we have done the analysis, right? Go to the respective table. They want the formula of the ions. So remember, you just write the formula, OH negative, and the half equations. Okay, and now describe briefly the chemical test for the product formed at the anode. You still remember the set 1, which forms the oxygen and water. So how you test the procedure? Remember, when we say chemical test, you must have the procedure and the result, which is the observation. When we are talking about procedure, make sure you mention what we're going to use, the reagent or the tool. Okay, so put the glowing water splinter into the test tube containing the gas. So your observation will be glowing splinter will ignite or burn, or you can say is rekindle or relights. Okay, these are the words you can use to describe. When you write like this, then you are entitled to get the 2 marks. Okay, so now we're going to compare the color of copper 2 sulfate solution in set 1 and set 2. Okay, as you can see here, experiment 1, if you still remember, the anode just now forms oxygen and water, and at cathode it forms copper. Okay, but for experiment 2, just now the anode, copper 2 ions are formed at the anode. Okay, at cathode copper metal deposited. So when we are going to talk on the color of copper 2 sulfate solution, first of all, what is the color of copper 2 sulfate solution? Is blue. So we have to consider about the intensity of the blue color of the solution. The blue color is either getting darker or lighter, is all determined by the concentration of copper 2 ion in the solutions. So if you compare experiment 1, look, cathode, the copper is depositing. That means what will happen to the concentration? Copper 2 ion concentration decreases, right? Copper 2 ions in the solution decreases. When the copper 2 ions in the solution decreases, what will happen? The blue color might change from blue to colorless. If you don't want to talk about blue to colorless, you also have another alternative way of answering, where you can write like this: the intensity of blue color of the solution decreases, because as you can see here, copper is depositing. How the copper can deposit here? Because all the copper 2 ions are coming out and depositing. So that will cause the copper 2 ions concentration to decrease. When the copper 2 ion concentration decreases, so it will get lighter. Okay, the blue color becomes lighter or paler, can. But make sure you mention the initial and after color changes. Okay, now let's look at experiment 2. When you come to experiment 2, you can see it very clearly, right? The anode forming the copper 2 ions. Anode forming the copper 2 ions. Remember, the copper 2 ions not coming out from the solutions. And cathode, the copper 2 ions will be discharged. So whatever the anode forms, going to go back to the cathode and deposit. So in this case, nothing will going to happen to the copper 2 ion solution from the copper 2 ion from the solution. So the concentration remains the same, unchanged. So when the copper 2 ion solution concentration remain unchanged, so the color intensity going to be the same, no difference. So that's why we write blue remains unchanged. Or you can say the intensity of the blue color of the solution remains unchanged, because the rate of the production of copper 2 ions at the anode equal to the rate of discharge of the copper 2 ions at cathode. So this causes the copper 2 ions concentration in the solution remains same. So that's the reason why there's no changes on the color. The darkness or the lightness are the same before and after. Okay. Okay, now let's look at this question. So as you can see here, you must be able to recognize that this is a voltaic cell, or is known as also chemical cell. When you get voltaic or chemical cell, as usual, same thing, you have to determine the terminals, which one is a negative and which one is a positive terminal. So how you assign them, you have to refer to their E0 values. Okay, so please kindly look at the table for E0 for copper 2. Allow the movement of ions and complete the circuit. So what are the optional or soluble salt usually we will use is sodium chloride, potassium chloride, or sodium nitrate, concept you have to apply here. The electron flows always happen from anode to cathode because anode undergoes oxidation, cathode reduction. So electron must flow from oxidation to reduction. So you put up the arrows like this. Okay. Next, state the color change of the copper 2 nitrate solution. Now again, the color of copper 2 nitrate solution is supposed to be blue. I want you to make some analyzing here. We know we are using copper electrodes. So copper is active electrodes, remember. So what will happen? Copper going to donate its electrons and form copper 2 ions. So these copper 2 ions will go to the source solution here. It's already blue. Now what happening to the copper 2 ions is keep on increasing. So intensity, the blue intensity increases. Why? You must give a reason. Because copper electrode ionizes, or you can say dissolve and ionizes to form copper 2 ions. So the number of copper 2 ions increases, or you can say concentration of copper 2 ion increases. And this is the half equation for the negative terminal. Okay, next, if copper electrode and copper to nitrate solutions are replaced with zinc electrode and zinc nitrate with the E0 value. Okay, now the E0 value for zinc now is negative 0. What happened to the voltmeter reading? So voltmeter reading is based on the E0 of the cell. So remember the formula will be E0 Okay, let's look at this type of questions. Always students are afraid to answer these questions. I don't know why. Okay, but now I would like to share with you a little tips on how to attend to this type of questions. So students, when you get an electron transfer at distance, what I will always recommend my students is go and see the type of solution they use at the both arms. Okay, and one more thing I want to tell you, if the beginning they use iron 2, that means after going to be iron 3. If they use iron solution, it's very easily you can identify. Okay, if they use 2, going to be 3. If they use 3, it's going to be 2. Now, based on this, you already know this side of the arm going to undergoes oxidation because 2 going to increase to 3. If this is oxidation, definitely this side going to be the reduction. And we know the electron transfer, the electron flows from oxidation to reduction. This is the flow. So these are the things you have to analyze. And upon that, one more thing you have to know about iron 2 is green, the color, and iron 3 is brown. Okay, these all are the basic knowledge you should have lah. Okay, so let's look at the question. State the color of iron 2 sulfate. So just now only I told you iron 2 is green. So you just state the color. Now, the same question now. When the circuit is completed, the galvanometer shows a deflection. So write the half equation for the reaction at X. So just now we already analyzed already. Iron 2 going to change to iron 3. And this is oxidation. So how you complete this half equation is 2 to 3. So must donate 1 electrons lah. Then it will change by 3. Okay. So you just copy back. Iron 2 going to become iron 3 by donating 1 electrons. And what type of reaction that occurs here, we already saw just now, that is oxidation. And let's say that the question asks you what the color change. Okay, potassium dichromate 6, the color change going to be orange to green. Always students get confused. Is it green to orange or orange to green? Can you see the O? So remember, it starts from orange to green. If it's acidified potassium magnate 7, then the color change going to be purple to colorless. This is all the famous solutions we use lah. You must know the color change. And when you get a transfer of electrons at distance, my recommendation, if they are using iron solution, it's easy for you to recognize. Once you identify the changes that happen to the iron, then the other partner automatically must be the opposite reaction. If the iron is oxidation, the other one must be reduction. If the iron is a reduction, then the other one must be the oxidation. So you can use the iron as an indicator for you to determine whether it's oxidation or reduction. Okay, let's say they don't give you iron, they give you a chlorine or chloride. So how to go about it? So students, remember, if they use chlorine, after going to become chloride. Sorry, after the reaction, it's going to become chloride. Okay, so for those who are not sure on how to identify whether it's oxidation or reduction, remember, this is molecule 0, this is -1, decreases. So this will be reduction. If it's other way around, let's say they use ions like let's say they use I do it here. Let's say they use a bromide. If they use ion, they are going to become molecules. The changes for halide is very easy. Halide ion become molecules. If they use molecule, they are going to become halide ion. That's all they are transformations. So now, if it's ion, it follow the charges. So -1. Now it's going to become 0. Molecule must be 0. Increase. If